Alright, so we'll continue on with this. So we have our starting x values, so I'll label that. Remember, this is not the horizontal shift. Actually, if we find the horizontal shift, which we don't need for graphing, this we would get by setting bx minus c equal to 0. This is our horizontal shift. Here, we also do not have a vertical shift because there's no d. Also, we're going to note A is 1/4. That is not our amplitude. If we were asked the amplitude, we'd say does not exist. Okay, so we're trying to graph two periods. So I know I start at -2. So this is my 5 tick marks for one period. So let's go ahead and do that first. Well, let's label these. This is -2, -1, 0, 1, and 2. And I'm going to put this in as 1/4, and this in as -1/4. Those values are coming from my A value. Now to graph this, I know I start with an asymptote, I end with an asymptote. The beginning point is going to be in the middle on my vertical axis, which is 0 because I have a vertical shift of 0. And then this was a positive tangent graph because A was positive 1/4. So my next point over is going to be up at 1/4, and then here I'm going to be down at -1/4. And that is going to be one period. We want to do two periods, so I'm going to put in 4 more tick marks. And I know that the end is an asymptote, and let's go ahead and continue to label these as well. So this is going to be 3, 4, 5, and 6, and I'll put in the points here, here, and here. So my tangent graph is going to look like that. And so again, we want to make sure we really understand that when we find this starting x value, that is not the horizontal shift. Our horizontal shift is actually the middle of the period, which is 0. Okay, now let's go on to cosecant. So we're going to first understand cosecant from sine. Well, cosecant is the reciprocal of sine, so I've graphed the sine curve here. It's in the red. And so if I graph cosecant, well, sine is 0 at 0. So what is the reciprocal of 0? Well, it's undefined. So that's going to be a vertical asymptote. How about 1? Well, the reciprocal of 1 is 1. So at pi halves, the cosecant function is also going to be 1. At pi, it's 0, sine is 0, so cosecant is going to have an asymptote again. At 3 pi halves, sine is -1, so the reciprocal of -1 is again -1. And then at 2 pi, sine is 0, so cosecant is again going to have an asymptote. Okay, so this covers one period, but it doesn't really give us an idea of what the actual curve looks like. So we're going to show a couple of more points. We're just going to estimate. But I know, for instance, at pi 6th, so I don't exactly see that here, but I can kind of estimate. At pi 6th, sine is 1/2. The reciprocal of that is 2. At 5 pi 6th, the same thing. Sine is 1/2. The reciprocal of 1/2 is 2. At 7 pi 6, sine is -1/2. The reciprocal of that is -2. And at 11 pi 6, sine is -1/2. The reciprocal of that is -2. So now those values help me see what the actual cosecant function, well, you get the idea, looks like. So what I drew in green here is the cosecant curve. The blue is the asymptotes. What you see here is one period of cosecant. So we'll continue on and fill in the second period here. These are going to be asymptotes. And if it's above the axis, it's going to go up. And if it's below the axis, it's going to go down. So now you see two periods of cosecant. And understand this is the accuracy that I would expect on a graph. You're going to just use for one period, you're going to have 5 points, just like you would with sine or cosine or tangent or cotangent. So we'll do a few practice ones after this, and we'll see what I mean. Alright, amplitude. Again, does not exist for the same reason as tangent and cotangent. Our definition of amplitude does not match what our graph has here. The period. Here we have to understand that the period is going to be 2 pi because it's the reciprocal of sine, and sine has a period of 2 pi. The domain, here we have to think in terms just like we did with tangent and cotangent, so it's going to be all real numbers. X does not equal, where's our first asymptote? 0 plus n times the distance between asymptotes. Again, you do not have to write the 0. I'm just writing that to be consistent. The range now for this particular graph is negative infinity to negative 1, including the negative 1, and then 1 to infinity. Alright, let's do the same thing for secant. I'm going to go a little bit quicker here because it's the same idea as what we just did. So for secant, at 0, cosine is 1, the reciprocal of that is 1. Pi thirds, cosine is 1/2, the reciprocal of that is 2. Here the cosine is 0, so the secant is going to be undefined. Since I already have this out, here is another asymptote. And then here I know at negative 1, the reciprocal is negative 1. At 2 pi thirds, cosine is negative 1/2, the reciprocal is negative 2. At 4 pi thirds, the same thing happens. And then here we're going to be at 1, and then at, this is approximately 5 pi thirds, I'm going to be at 2. So 1 period of the secant function is, again, what I'm drawing here in green. And now if we continue on to draw another period of the secant function, so that picture right here is 1 period. I'm going to use a different color to show you the distinction between 2 periods. So here we'll still have our asymptotes. And then this is going to connect here. And it's going to look like that. So this is 2 periods now of the secant curve. But again, what I've drawn, the green is 1 period, the purple is another period. Just like with cosecant, amplitude does not exist. So DNE. Period is 2 pi again. Domain. Similar to before. So all real numbers, x does not equal. Our first asymptote here is at pi halves plus n pi. Pi is still the distance between asymptotes. Remember, this number here is representing a distance. And then the range is the same as what we had for cosecant. Negative infinity to negative 1. 1 to infinity. Okay, so what are our strategies for graphing cosecant and secant? We want to graph the points for the respective sine or cosine function. So we're going to treat it as if it's a sine or cosine, understanding that it's not, graph the points as if it was sine or cosine, and then just draw the curve for secant or cosecant. Alright, so let's do an example of this to make sure we understand what I'm talking about. Okay, so here I have y equals negative 2 secant of 3x plus 2, so I'm going to treat this as if it was y equals negative 2 cosine of 3x plus 2. So my amplitude does not exist, but A is still going to affect the graph, so I want to recognize that's negative 2. My horizontal shift I get by setting bx minus c equal to 0, so x equals 0. That's my starting x value and my horizontal shift. Vertical shift is positive 2, and period is 2 pi over b, which is 3, which leads me to intervals of 2 pi thirds over 4, which is going to be 2 pi over 12, or pi over 6. So now I know all of my information. I'm going to draw my axis. I had a positive vertical shift of up 2. So let's say that this is at 2. I had an A value of -2, so I'm going to go up and down. Let's call this 4, and then that's 0 obviously. And we're starting at an x value of 0 and then going up by pi 6. So at 0, this is going to be 1 period. So I'll mark these off. This is pi 6, pi thirds, pi halves, 2 pi thirds. So this is going to be 1 period. I know that, remember, I'm treating this as if it's cosine. So this would have been a negative cosine. So the first point would be down here, then up, then here, and then down. Everywhere that we cross the axis, we're going to have an asymptote. And then the other places, we're going to curve down if we're below the axis. And we always curve towards the asymptotes. And we're going to curve up if we're above the axis. So that's 1 period. I'll continue with another period though. So if this was 2 pi thirds, then we are going to have 5 pi 6, pi, 7 pi 6, and then 4 pi thirds, and I can continue on with the pattern for cosine. So you can see again what I'm trying to point out is the dots that I've drawn in black, those would be the same dots that I would draw if I was creating the cosine function. And then I'm just going to continue on drawing the curve. So that is 2 periods of the secant curve. Alright, let's do a couple more examples. So I want you to graph 2 periods of y equals -2 cotangent of the quantity 3x minus pi. Pause the video and unpause when you're ready to check your work. Alright, this is what your graph should look like, hopefully. Let's talk real quick about how we got that. We have an A value of -2. Our amplitude does not exist. I'm just trying to make sure we remember that those relate, but they're not the same. The vertical shift is 0. Our horizontal shift, which is also our starting x value for cotangent, is x equals pi thirds. The period is also pi thirds. The interval are pi twelfths. So now I'm going to start at pi thirds and count up by pi twelfths. That's how I got all of my values. A was -2, so I marked down -2 and 2. I start with an asymptote, I end with an asymptote. The middle point is on the axis. The axis was 0 because I had no vertical shift. This was a negative cotangent graph, so the values flip. So this actually looks like a positive tangent graph. And that's how I came up with my points. Okay, now I want you to try and graph y equals 3 cosecant of 2x plus pi halves minus 4. Pause the video and unpause when you're ready to check. Alright, this is what your graph should look like, hopefully. The black is the cosecant function. So let's make sure we understand how we got that. A is 3, amplitude does not exist, horizontal shift is -pi fourths, vertical shift is -4, the period is pi, and the intervals then are pi fourths. So I did my vertical shift. I started with a horizontal shift of -pi fourths and went up by intervals of pi fourths. That's how I got all of the x values. And then the blue dots are the points as if this was a sine function. So I first treat it as if it's a sine function, plot those points. Wherever I cross the axis, I have vertical asymptotes. If I'm above the axis, I draw the curve going up towards the asymptotes. If I'm below the axis, I draw the curve going down towards the asymptotes. Alright, so here's our conclusion. Trying to just refresh or summarize how to graph cosecant, secant, tangent, and cotangent.